Year 11. I'm going to go over what we did in class today, which was rationalising the denominator. Now, as I said in class today, there's not a great use for this anymore because we can use a calculator. But before the time of calculator, rationalising the denominator of fractions allowed people to do calculations with these. And it's going to be useful later on when we do some more difficult work with algebra in Year 12. So I'm going to start with question 1. And we'll have a quick look at these. I'm going to do some really quick ones. So 1 over root 7. Well, this one's pretty easy because all I have to do is multiply the bottom by root 7. And that'll get rid of the square root because root 7 by root 7 is 7. But I can't just do that. I can't just multiply one part of the fraction. I must do the same thing to both parts. And multiplying by root 7 on 7, well, that's like multiplying by 1. It doesn't change the equation. It just alters the way it looks. So 1 times root 7 gives me root 7. And root 7 times root 7 gives me 7. And now if I were doing an operation with that fraction, it's a lot easier because I have a 7 in the denominator, which is what I have to change. Either add, subtract, or any of those things. Let's have another look. We did A, C, E, G, and I'm going to have a go at I. So that's 1A. I'm going to go at I. So I is 8 plus 3 root 2 all over 4 root 5. Now immediately some of you will be thinking, oh, I'm going to multiply by 4 root 5. Well, you could, but that would make it difficult because you'd have to simplify that a little bit later on. We just want to get rid of the surd on the bottom. So I'm just going to multiply by root 5 on root 5. Now, if I do the top, I've got two things here. I've got 8 times root 5, and I've got 3 root 2 times root 5. Well, 8 times root 5 is 8 root 5. And 3 times root 2 times root 5 is 3 root 10. And on the bottom, I get 4 times root 5 times root 5. Now, root 5 times root 5 is 5. And 4 times 5 is 20. So you're going, well, that's pretty easy. That's not hard. And you're right, it isn't hard. But what about question 2? Let's have a look at the first one, 2a. What have I got? 4 on root 3 plus root 2. Now you think to yourself, oh, I'll just multiply by root 3. Well, that'll get rid of the surd for the root 3, but it'll make the root 2 a root 6. Oh, you go, oh, well, I'll multiply by root 2. Well, that'll be okay for the root 2, but that'll make the root 3 a root 6. A bit difficult, this. Well, this is where we're going to use this special law. And you should know this. It's called the difference of two squares. And if I have something plus something times something minus something, well, that'll equal the difference of two squares. Now, if I can do that here, I can get rid of both the root 3 and the root 2 at the same time. Well, that's something plus something. That's root 3 plus root 2. So I'm going to multiply by root 3 minus root 2, top and bottom, which is like multiplying by 1. And that will help me do it. Now, knowing what to multiply by brings up this word that we use called the conjugate. We are multiplying the denominator by its conjugate. And the conjugate is this. The same thing with a different sign. Well, let's see what happens now when we do this. Well, I get 4 times that and 4 times that, so I get 4 root 3 minus 4 root 2. Now here on the bottom, using this law, which you need to put up on your bathroom wall or above your study desk, somewhere where you're going to see it every day, put it beside the bathroom mirror, and you'll see it every day when you brush your teeth. So this will mean I get the first thing squared. Well, root 3 squared is 3, and root 2 squared is 2, and it's the difference, so I subtract them. So I get 4 root 3 minus 4 root 2. 3 minus 2 is 1. And when I divide anything by 1, it's just whatever is on the numerator. I don't need the 1 there. Well, that's A. C is pretty much similar. Let's do E. So E is root 2 plus 5 on root 3 minus root 2. Well, immediately, the first step, let's multiply by the conjugate. Well, this time the conjugate is root 3 plus root 2. I'll do that top and bottom. Now on the top, I have 2 things by 2 things. So I'm going to get 4. I'm going to get root 2 times that, and root 2 times that. I'm going to get root 5 times that, and 5 times that. So let's do it. Root 2 times root 3 is root 6. Root 2 times root 2, well, that's just 2. 5 times root 3, that's 5 root 3. And 5 times root 2 is 5 root 2. On the bottom, well, root 3 squared is 3, minus root 2 squared is 2. So I'm going to get root 6 plus 2 plus 5 root 3 plus 5 root 2. And I don't need to change that because it's all divided by 1, and I'm going to leave that as it is. Okay. Well, 1 and 2 were pretty easy. What's going on with 3? Well, we'll do 3a, which is 1 on root 2 plus 1 plus 1 on root 2 minus 1. Well, the first thing is I wouldn't write it like that. What I suggest to you is you leave yourself a little space. And this is what I mean. Plus, actually I wouldn't put that plus there, plus 1 on root 2 minus 1. So why do I leave a little space? Well, I'm going to multiply each of these by their conjugate. So root 2 minus 1, and root 2 minus 1, and root 2 minus 1, and root 2 minus 1. Sorry, they're pluses. So what do I get? Well, let's just do the first one. Well, 1 times that is root 2 minus 1. And I've got the difference of 2 squares. Root 2 squared is 2, minus 1 squared is 1. Then I get plus, well, 1 times that is root 2 plus 1. Root 2 squared is 2 minus 1. And I'm really lucky because I get root 2 minus 1 plus root 2 plus 1 on 1 on 1. Well, that's just root 2 minus 1 plus root 2 plus 1. The ones will cancel, but I'll get 2 root 2's, and that's my answer. Well, that was pretty easy. We don't need to worry about this. Well, it does get a little bit tricky. Let's have a go at 3c. And what happens in 3c? I get 1 on root 5 plus root 2. Leave a gap. and I get 3 on 3 root 2 minus root 5 plus 3 root 2, sorry, 3 on 3 root 2 minus 5. Three on 3 root 2 minus root 5. Multiply by the conjugate, root 5 minus root 2 on root 5 minus root 2. And the conjugate here, 3 root 2 plus root 5 and 3 root 2 plus root 5. Okay. Well, 1 times that is pretty easy. I get root 5 minus root 2. And the difference of 2 squares underneath, I get root 5 squared, which is 5, minus 2 squared, root 2 squared, which is 2. The other one, look at this. I get 3 of those and 3 of those. Well, 3 times 3 root 2 is 9 root 2. And 3 times root 5 is 3 root 5. Now here's the hard bit. Underneath, I've got to square that. Well, 3 squared is 9. Root 2 squared is 2. 2 times 9 is 18. Root 5 squared, well, that's just 5. So I get root 5 minus root 2 on 3 plus 9 root 2 plus 3 root 5 on 13. Okay, well now I have to make a common denominator. Well, that's all right. I remember my fractions from my early years. If I multiply that by 13 and 13, and multiply that by 3 on 3, I'll get a common denominator of 39. So 3 13s are 39. 3 13s are 39. And now I'll just do this here. 13 of those and 13 of those. So I get 13 root 5 minus 13 root 2. Here I get 3 of those and 3 of those. 3 9s are 27 root 2s. And 3 3s are 9 root 5s. Well, now I can add them together. 13 root 5s and 9 root 5s. Well, that's 22 root 5s. Minus 13 root 2s and 27 root 2s. Well, that's plus 14 root 2s. And my common denominator is 39. And that's the answer to question 3C. Okay. Question 3G is long, but not that hard. I is pretty easy. I want to have a look at, K is going to give me K. I'm going to have a look at K. 2 plus root 2 plus 7. So I'll do it here. So here's 3K. Root 2 plus 7 on 4 plus root 3 minus root 2. What did I say? Leave a gap. Minus root 2 on 4 minus root 3. So I've got to multiply by the conjugate. Well, here the conjugate is 4 minus root 3 and 4 minus root 3. And here the conjugate is 4 plus root 3 on 4 plus root 3. Okay. This first one's going to be hard because I'm going to go two things by two things. So I'm going to root 2 times that and root 2 times that. And you get 7 times that and 7 times that. So here we go. Root 2 times 4. Well, that's 4 root 2. Root 2 times root 3. Well, that's minus root 6 because there's a negative there. 7 times 4, 28. 7 times root 3 minus 7 root 3. All over. 4 squared, 16. Root 3 squared, 3. There's the first one. Fortunately, the second one's easier. It's just root 2 times that and root 2 times that. Put the minus in. I get 4 root 2 plus root 6. And it's all over 4 squared, 16, minus root 3 squared, 3. Well, this is going to be good. I'm not going to have to get a common denominator because I'm already going to have one. 4 root 2 minus root 6 plus 28 minus 7 root 3 minus 4 root 2 plus root 6, and they both have a denominator of 13. Righto. So, what are we going to get here? I've got 4 root 2's. Oh, and I'm minusing root 2. Well, 4 root 2 minus root, oh, that's just going to go. This is the hard bit. I've got minus root 6 minus another root 6. So I'm going to get minus 2 root 6. And then I've got a 28. So plus 28 minus 7 root 3. We're all over 13. Well, I'm just going to put that 28 to the front. So I've got plus 28. I don't need to write the plus. I've got a minus 2 root 6. And I've got a minus 7 root 3. All over 13. And that's correct. So as you can see, they're a little bit hard. I want to do one more from 4. Sorry, not from 4. I want to do one of these more difficult ones where they say write it in A plus B. Well, they haven't got one. Yes. I want to do E, 4E. And then you can have a go by yourself. So 4E, because this is how they like to ask it in the HSC. 2 plus 3, root 2 plus 3, and root 2 minus 1. Righto. And they want me to write it as A plus root B. Okay, let's have a go. First of all, the conjugate. Root 2 plus 1, root 2 plus 1. Okay, well, I've got binomial here, so that times that, and that times that, root 3 times that, and 3 times that. Here we go. Root 2 times root 2, 2. Root 2 times 1, root 2. 3 times root 2, 3 root 2. 3 times 1, 3. All over, well, root 2 squared is 2. 1 squared is 1. Well, this is pretty easy. Now, 2 plus 3 is 5. Root 2 plus 3 root 2, well, that's 1 root 2 plus 3 root 2. That's 4 root 2's. All over 1. Well, that's just 5 plus 4 root 2. But remember, they wanted us to write it as A plus root B. And I've got an A, I've got that 5, but I've got 4 outside. I better put that back in, so I'll get 5 plus, well, 4 is root 16, root 2. 5 plus, well, 16 times root 32. That's a bit unusual. And they won't ask that in the HSC, but now I've got it in the form A, and the A is equal to 5, plus root B, and the B is equal to 32. And we'll just check that. Oh, I did it, you silly duffer. That's a B. And A equals 5 and B equals 32. Now, we're going to continue on with these tomorrow, but I want you at least to be up to question 4. Make sure you know how to multiply by the conjugate and how to write fractions with a rational denominator.